Hi, in this problem, we are going to talk about the projected present value of an ordinary annuity. And this concept is better illustrated with an example. So we're going to solve this problem. So there is this this pension fund manager in Germany who anticipates or expects to pay benefits of 1 million euros per year to retirees. Okay, so he expects to make a payment of 1 million euros per year. Okay, except that this payment does not begin until the 10th year, which begins to be paid at the 10th year, right? And it will go on to be paid until 39th year, right? So this is going to be a total of 30 payments, okay? Now, the thing is, what what is the present value of this liability? Like at t is equal to 0, how much money should this pension fund manager have or should invest in another fund at 5% interest rate so that at the 10th year he will have enough money to start paying 1 million per year starting at the 10th year up until the 39th year. So again, this kind of problem will become clear if we draw a timeline. So let's draw a timeline. Here is a timeline. So we have timeline of 10 and timeline of 39. So let's do this 10 and let's do this 39th year. This is time. So the first payment will happen at the 10th year. So the first payment occurs here, euro of 1 million. And this is first payment. And at the 11th year, there will be another 1 million payment, and that will be the second payment. At the 12th year, but there will be another 1 million payment, and that will be the third payment, until the 39th year, and this will be the 30th payment, right? And then here 38, the 38th year, and there will be another 1 million payment here, and that will be the 29th payment, and so on. So we have the 9th year here, and then let's just do 0, 1. We can't write all the numbers here, so let's just do this. So the question we're asked is, how much money should he has at the present time today, so that with 5% compounding, with 5% interest rates, he will have enough money around this time to start paying 1 million per year for the next 30 years. So let's see the timeline from here onwards. Now this looks like an ordinary annuity. That means if we treat the 9th year, which is T9, as T0 and T10 as T1, then this will become an ordinary annuity problem, right? Where the first payment occurring at the first year. So T10 being T1 and T9 being T0. So the, the formula we have to calculate the present value, of an ordinary annuity is the annuity amount 1 minus 1 over 1 plus r raised to n divided by r. So we have 1 million euros multiplied by 1 minus 1 over our interest rate is 5%. So 1 plus r, that's 5% raised to n. How many years? 30 years, right? Divided by 0.05. Now, this will result in 15,372 and 451 and 03 euros. Now, this is the amount of money that this pension fund manager should have at t is equals to 9. So at t is equals to 9, if he has this amount, then he will have enough money to pay $1 million per year for the next 30 years. So let's just cut this timeline and draw it again here. So if I draw this timeline again, and here 9th year, 0, 1. So at the 9th year, he should have this 15,372 and 451 and 03 euros at the 9th year, so that he will continue to pay 1 million euros per year for the next 30 years. Now the original question asked is that this is the amount of money he should have at the 9th year, but what about now? So this is going to be a very interesting problem. So now we calculated this 15 million euros as a present value, but that's from the perspective of this 30-year annuity period. But for now, if you wanted to calculate how much he should have at this time is equal to 0, then this amount at t is equal to 9 becomes a future value, right? And the relationship between present value and future value is simply this. So we know from our first lecture that future value is simply present value times 1 plus r raised to n, right? This simply gives us that present value equals future value divided by 1 plus r raised to n. So for this problem that we have, right, our future value for the problem we have here, our future value is this amount. Right? Our rate is still 5% or 0.05. And our n is 9 years right now. 8 years. This is the first year, second year, and so on. And this is the 9th year. So our n is 9. So now we calculate the present value. This present value is the amount at t is equals to 1. And this future value is at t is equals to 9. And this is, now we have the present value 0. The present value at time is equal to 0. Here, present value is simply the future value at t is equals to 9, which is this amount that we calculated from here, divided by 1 plus r raised to n, and this is simply 15,372 451.03 divided by 1 plus 0.05 to the power of 9, and this will give us about 9,909,219 euros. Now let me draw this timeline again and try to understand the solution in the context of this timeline. And the most important times are 0, 9, 10, and let's do 39 here, and this is time. Okay, so, and our interest rate is 5%. So this person, this fund manager, should have 9,909 and 219 euros today. This is today. So that he can begin to pay his retirees 1 million every year, 1 million every year for the next 30 years, starting from the 10th year. But initially though, we only knew of this 1 million payment every year that's to be made after the 10th year, up to the 39th year. We knew the rate, which was 5%, and we knew that this problem was an ordinary annuity problem. So assuming that forgetting this timeline, we started from time 9, or the 9th year, and treated it as its own, like treating T9 as T0 and T10 as T1, and using an ordinary annuity formula, we determined that he should have this 15 million euros at T is equal to 9. Once we found the amount of money he should have at T is equal to 9, using the simple relationship between future value and present value, we calculated how much he should have at T is equal to 9, at T is equals to 0. So this is basically how you solve this projected annuity problem, present value of an annuity problem.